All right, these are our notes for lesson 6-1. It is volume of rectangular prisms. I went ahead and pre-wrote some things on my page just so that we wouldn't have a lot of dead air time. And then the work that we actually do, I'll do along with you. Typically in class, I would give you time to catch up, but on this, you can just pause the video and finish writing what you need to and then move on. So this is 6-1, and then we'll also be doing workbook pages 245 to 248 in our workbooks, the one with the wolf on them. So we are starting volume. This is likely a review for many of you, but that's okay. We're gonna get into a little bit more complex things using fractions. And so just reviewing the basics first before we move on. So first I wanna talk about the difference between surface area and volume. So for surface area, that's the area on the outside of the figure. If I pick something up, it's what I can feel with my fingers. So we did a whole unit about this. I can't remember which one it was, but it would be like, how much wrapping paper do I need to cover this box? Or how much glass did it take to make the aquarium? Okay, and so for surface area, I have this figure here, a rectangular prism. Let me find my pen to label it. And its sides are 4 inches, 2 inches, and 3 inches. Okay, so we know that we need to find the area of each of these faces on the prism. And so we're using area equals base times height of each of those. And so the first one I'm going to do, it doesn't matter what I do first. I'm gonna do these faces here. They're opposite each other on a rectangular prism, so we know that they're equal, even though my drawing is not quite perfect here. And so the dimensions of this face, it has a base of 2 and a height of 4. So I'm gonna do 2 times 4, and that equals 8. And then how many of them are there in this instance? So I just told you that there are 2 of them. Remember that when we did pyramids, it was a little bit different. There would only be one base, and then, well, yeah. Okay, so I'm gonna multiply it by 2 for a total of 16. And then I'll move on to my next set. I'll do this one, the top and the bottom. So these ones are 2 times 3. So the total for this one is 6, and there are 2 of them in this instance. So I'm gonna multiply it by 2 for a total of 12. And then I still have one set of faces that I haven't done yet. And those are these ones here. Okay. And their dimensions are, this is getting kind of messy, but their dimensions are 3 by 4, which is 12. There are 2 of them. So I'll multiply by 2 again for a total of 24. So now I have the area of each of these, but I need to add them together to get the entire box. So if I add those together, I have a total of 52. And then if you remember, of course, we have to label it inches, and that is squared when we do surface area. So just remember that we are doing squared for surface area. This should all be a review for you. Okay, so moving on to volume. Here's the difference between surface area and volume. Volume. The volume of a figure is the amount of space occupied by it. It includes the inside of the object, or the part in the middle that my fingers can't touch. Okay, so we're looking at how much space does this object fill up? Like how much water would I need to fill a fish tank? Or how many milk cartons can I fit inside of a crate? Okay, so filling up that inside rather than just going around the outside. So I have a couple more figures for you here. Yesterday when we were on Zoom, we talked about how we talk about this kind of shape and how they would be labeled. So I'm gonna go over that with you and then tell you what it is that Expressions is using just for the sake of this unit. So for this here, we have the height. We're all familiar with that. We've been using height. And then for this here, we've been using base. But another thing that we could call this right here would be the width. And then we have the length right here. And you might also know it as the depth. Okay, so all of those will work, but in Expressions, they're using height, width, and length. Okay, so our formula ends up being volume equals length times width times height. So right before we left school, we also looked at the commutative property. So we actually know that this could be volume equals width times length times height. It doesn't matter what order they're in because they're all going to get multiplied by each other. Okay, so these are all actually the same thing because of the commutative property. I'm just stick with this one because that's the way that I have it in my head. All right, so I'm gonna use the same figure here. I have the same figure and it is going to be 2 inches. So I'm dividing this into my cubic units. 2 inches by 4. 1, 2, 3, 4, and then those wrap around this way. By 3 inches. 1, 2, 3. Okay, so that is not perfect, but that's okay. So the first thing that I'm gonna do, or the first way to think about this, is when I multiply, so say I do length times width times height. Again, it doesn't matter what way you really do it in. I shouldn't even have put a square around that because I just first see the height and the width right here. So I think to multiply those together. And so when I do that, I'm counting all of these cubes that are making up this figure. It's like taking the first layer off of there. So if I counted these, I wish I had some cubes for you guys, but we're not at school, so we don't. 1, 2, 3, 4, 5, 6, 7, 8. So I could count them and see that there are 8, or I could just do 4 times 2. And then I have this first layer, and then I have to think of, well, here's another layer of it, and here's another layer of it, and that's where that 3 is coming from. So I'm gonna write out 4 times 2 times 3. And then just using PEMDAS, I'm gonna move, I have all multiplication, so I'll just move from left to right. 4 times 2 is 8 times 3. And 8 times 3 is 24. Okay, so here's our answer, 24. And this is just labeled different than surface area is. So for volume, this is going to be inches cubed instead of squared. Inches cubed for volume. So, I mean, you're using cubes, you're using 3 dimensions. So you have 3 dimensions. You need the length, the width, and the height to come up with the volume. So that could help you remember. Length, width, height are 3. You're using a cube. You need 3 dimensions. Whereas in this, the 2, you're just doing base times height. You only need 2 dimensions to get the surface area of this one red face right here. So that's why this one is squared. This is just a square. It's not 3-dimensional. And this is cubed. This is a 3D figure. All right, so those are the very basic notes for this. It goes on into fractions in the upcoming lessons. So I'm gonna go through workbook pages 245 to 248. I will have you, here's my workbook. Why don't you pause right here? And try to solve these, and then I'll just go through and I'll do the answers with you. Okay, I also just realized I need to grab another pen because you guys know that these bleed through. Okay, hopefully this one will work. Okay, so pause right here and take a stab at these, and then I'm gonna go through right now and do the answers for them. So this is the notes that we just took. The volume of a solid figure is the amount of space occupied by the figure. Volume is measured in cubic units. Cubic units. So sometimes we might know that it's an inch, or it's measured in centimeters, or it's measured in feet. But sometimes we might not know how many units it is or how big the unit is, so we can even just say unit for that. Okay, so number one, how can you measure the amount of space each of these rectangular prisms takes up? How much space is inside each of the rectangular prisms? How many unit cubes does it take to fill the rectangular prism? So there's a lot of different answers for these ones. But for instance, you could choose a cubic unit. So if you had cubes that were a centimeter or cubes that were an inch, you could choose your unit and fill the box with them, or the figure. And you could choose whatever you wanted as long as you labeled it appropriately. Without overlapping or gaps. You want to fill the entire figure. So that's why those cubes, they fit together perfectly. You can also multiply length times width times height to find the volume. This would be if you were able to measure it. Okay, moving on. A unit cube is a cube with each edge 1 unit long. The volume of a unit cube is 1 cubic unit. It can be written 1 cubic unit or 1 unit cubed with that 3 right there. Okay, so this is just getting used to using this language. Label the length, width, and height of the centimeter cube on the right. Write the volume of a centimeter cube in 2 ways. So this is maybe kind of difficult to understand what they're asking you to do. But if I have this and I know that it's 1 centimeter cubed, it's going to be 1 centimeter in every direction. Or I can call it 1 cubic centimeter. So this word cubic is special to this kind of math. Cubic, we don't really use that anywhere else. 1 cubic centimeter or 1 centimeter cubed. That's 2 ways to write that. So using these, how could you go through and do 3 through 6? If you haven't done them yet, go ahead and pause and complete those right now. Now that you have an example, they should be easier to do. So number 3 will be 1 cubic inch or 1 inch cubed. For the meter cube, we have 1 cubic meter, or 1 meter cubed. For the foot, 1 cubic foot, or 1 foot cubed. Just getting used to using this cubed and also this word cubic. And for yard, 1 cubic yard, or 1 yard cubed. Okay, let's move on to the next page. Okay, so we did not cut out the nets on the first page here just because we're not in class. I thought that would be really difficult for me to try to do under here. But we'll just look at this cube right here because this is one of the ones we would have made. Okay, so it is 1 unit in each direction. We don't know how much it is, so it's just a unit cube. It's just 1 unit. We don't know how big this is. Okay, so what is the surface area of the unit cube right here? So this is surface area, not volume. So I know that this is 1. This is 1. And this one going back, the length or the depth is 1. So to find area equals base times height. So I'm going to have 1 times 1. And that is 1. It's a cube, so I know that I have 6 sides that are all the same. So I'll multiply 1 by 6, and I get 6 units. And think about if it's going to be squared or cubed. All I did was the surface area, looking at these 2-dimensional cubes, or not cubes, I'm sorry, that's a 3D thing. 2-dimensional squares that are all put together. So its surface area, it's just squared. Okay, what is the surface area of an inch cube? So same thing, if I had a cube just like this, but each of these were an inch instead of a unit. Okay, now they're each 1 inch. Again, I have area equals base times height for each of those faces. They are 1 inch, so it's 1 times 1. And it's still a cube, just an inch cube, so times 6 equals 6 inches, because now I know that my unit is an inch squared. How is volume different? Number 9. How is volume different than surface area? Oh no. Oh, I thought my thing had stopped recording. My phone memory is pretty full, so it's likely that that could happen. How is volume different than surface area? So surface area is the total area of the flat faces. If you don't remember the terms like faces, you have them in your notes so you can go back and refer to those. Surface area is the total area of the flat faces, and volume is the amount of cubic units and again, we might know that our unit is an inch or in centimeter, or we just might not know, but we can refer to them all as units that fit inside the object. Number 10, how is the unit used to measure surface area different from the unit used to measure volume? Okay, so we have just been talking about that. Surface area is two-dimensional. All I'm really doing when I'm measuring surface area is this square or this rectangle. It's just the base and the height of it. There's nothing else to it. This is just something that I can just draw on a piece of paper. Okay, it doesn't have any depth to it or any length going back. So this is two-dimensional, and that's why it's units squared. All this is a square. And volume measures three-dimensional objects. Okay, so since I'm looking at the inside, let's see. So when I have this, I'm looking at the whole of it, even the inside. You can picture all this grid going across it right here. So I have a base and a height, and then a third dimension, the length going back that I need to measure. So that's why it is units cubed. Number 11. What is the surface area and volume of the prism you made? So again, we didn't make these prisms, but they are right here. So our surface area, we're just looking at what it takes to go around the outside of it. So I could do the math here, let's see. Or you can just count them in this case. I don't know which is best to do for this because they have the shape all broken apart. Surface area is going to be our blue pieces. And volume is green. The green cubes inside. And I'll let you guys decide how it is. You could do it the algebraic way or you could just count them. But we end up with 34, I'll do this so that you can check your answer, centimeters squared or 10 centimeters cubed. Write a formula for the surface area of the prism. Okay, so going back to that, I guess they do want us to do it the algebraic way. So write a formula for the surface area of the prism. Okay, so here's our width, is this part of it here, and you can see it's labeled. Our length is this long part, L, and our height, they have labeled here. Okay, so I'm gonna do, this is a rectangular prism, so they're each times 2. So I'll do 2, to get this, I would do width times height, plus, I'll do this one next. This one is length times width. And the last one that I have is here, height times length, yeah, for these ones. 2 height times length. Okay, write 2 formulas for the volume of a rectangular prism. Volume equals length times width times height. I'm not gonna do this second one with you guys yet because I'm gonna save it for later on when it actually comes up. But there is another way to do it as well, but the one that I just gave you in this was length times width times height. My times kind of got lost in there. Find the surface area and volume of the prisms. Okay, so I'll let you guys go through and do the work on these, but the answers are 150 inches squared and 125 inches cubed. So remember that for surface area, you're doing each of the faces and then adding them together. And the volume is length times width times height. Number 15, the surface area is 114 feet squared and the volume is 72 feet cubed. And number 16 is 94 surface area, 94 centimeters squared, and 60 centimeters cubed. Whoops, that's not showing. Okay, we're gonna skip 247 because it's Puzzled Penguin, and go on to 248, which has some word problems on it, your favorite. So choose the most appropriate measure. Write perimeter, surface area, or volume. Let's do 19 through 24. Go ahead and pause right now and do those. And then I'll go through and talk about them. Okay, so we haven't talked about perimeter until now, but you guys should know, you've been talking about perimeter for a long time. The perimeter is the distance around something. So just around something two-dimensional. So like a fence around a yard, or this line right here. Okay, so which would be the most appropriate way to measure? Right, perimeter, surface area, or volume. The distance around a building. So like I just did here, if I had a building and I wanted to know what the distance would be to go around, that would be my perimeter. The amount of wrapping paper on a gift box. So for that, you're gonna be covering, let's say that the gift box is a rectangular prism, like what we have been dealing with in this lesson. How much to cover each of the faces of that? That is surface area. The amount of sand in a sandbox. So the sand is filling that box, so we're talking about what's on the inside of it. That is volume. The amount of wall space in a room. So if I wanted to cover the wall with paint or something, how much would I need to cover all of that? So I'm looking at a wall that is two-dimensional and has a base and a height. So that is surface area. The length of a fence around a yard. So I'm going the distance around the yard, just like I did with this building. That's perimeter. And the amount of peanuts in a container. So those peanuts are filling the container all through the inside. So I'm looking at the volume. All right, let's have you pause again right here and do 25 through 28, and then I'll go over them with you. We're almost done here. Okay, number 25 says, how many cubic feet of water will it take to fill this aquarium? What is the open surface area of the water? Okay, so I have two different questions here. Let's see. Open surface area. Okay, how many cubic feet of water will it take to fill the aquarium? Cubic feet to fill it. So I'm talking about volume here. So I know that my formula for volume is length times width times height. So let's see if I have those numbers. I have a length, 3,